is capital E with the square brackets. This stands for expected value, and normally it's put in, you got an X in the middle there. So this means expected value, in this case, of X, and X is a random variable. Expected value can also be known as the mean, the average. Average is probably the word that you'll be most used to at the moment. They can also use the Greek letter mu. It's also known as the first moment. Moments are a later concept in probability theory. Different names for similar things. So let's look at average as the starting point. So just to make sure that you know what an average is, we'll look at a simple example. Just say we want to roll a 6-sided dice 3 times. We want to find the average number. So the average of the rolls equals all values added divided by the number of rolls. So just say we rolled the dice 3 times and we got the values 1, 5, and 2. That means if we're going to add all of those values, we've got 1 plus 5 plus 2 divided by the number of rolls, 1, 2, 3. This can also be written, remember, as 1 over 3 plus 5 over 3 plus 2 over 3. So again, different ways of writing the same thing. The way of looking at it here will become more obvious when we proceed further. So adding these together, 1 plus 5 plus 2 equals 8 over 3, which equals 2.6 recurring. So 2 2/3. So that is just the average of 3 rolls. So just say we wanted to roll a dice millions of times, like many, many times, more times you can count, and we wanted to know what the value we would expect this to be. And this is where probability comes in, so the chance of getting a particular result. So we've got a 6-sided die, got the numbers 1 to 6, and each of them has an equal chance of being rolled. Let's assume they have an equal chance of being rolled. So if we put that in a table, we've got a value that we can get and the probability of getting that value, or the chance of getting that value. We have the values 1, 2, 3, 4, 5, 6, and because they've equal chance of coming up, we've got 1 chance in 6, 2 chances in 6, that's not right, 1 chance in 6, 1 chance in 6, 1 chance in 6, 1 chance in 6, 1 chance in 6. So you can see that all of these add up to a total of 1. So the probability of rolling any of these values in a single roll is 1 in 6, but the probability of rolling each of these values, or all of these values, is 1. So your probability is going to go from 0 to 1, or 0% to 1%. So if we were going to find our expected outcome based on these chances, we're going to use our form that we've used before. And go 1 over 6 plus 2 over 6 plus 3 over 6 plus 4 over 6 plus 5 over 6 plus 6 over 6. And what we've done here is we've multiplied the value that we're going to get with the probability of it's happening. So 1 multiplied by 1 over 6, 2 multiplied by 1 over 6, 3 multiplied by 1 over 6, etc. So in math notation, we'd write this as this symbol, which is another Greek letter called sigma, and it means to sum everything together. And we're setting an iterator with the variable n, which goes through each of these values. So n is going to equal 1, and then 2, and then 3, and then 4, and then 5, and then 6. And the way that we write this is we put from n equals 1 to n equals 6. So that's the beginning, that's the end. And we have our value. And for each number, for each n, the value has a particular value ascribed to it. So I'm going to use a subscript of n down here, and I'm going to multiply that by the probability of getting that value. So we're just doing exactly what we have in the table here. So for each n, for n equals 1, we find the value for 1 and the probability. We multiply those together, and then we move on to 2, multiply those together, and then add them to the first one, multiply n equals 3, add them to the first 2, etc., etc., until we get our final result. In this particular case, all of the probabilities are equal, but sometimes they're not, and this is where functions come in. But we'll look at that a bit later. So we can redo this. Since the probability is the same, we can even look at it as summation from n equals 1 to 6 of all of the values divided by 6. So that's easy enough. And in a more, which when we complete that, equals 1 plus 2 plus 3 plus 4 plus 5 plus 6 over 6, which equals 21 over 6, which equals 3.5. Easy to see halfway between our lowest and highest values, given they're equally spaced. So more generally, we can look at this form and put it as the summation from n equals 1 to m, where m can be bigger than 1 up to however many values we have. So it could be n equals 1 to infinity. It could be up to 50, depending on how many values you have of our value, which we'll call x subscript n, multiplied, and I'm just using the dot in this particular case to show multiplication, the probability of xn. So sometimes that probability can change. This situation with the summation sign is for discrete probabilities. Discrete probabilities are essentially just individual definable events. Like you can see distinct gaps between them. For example, you can see definable event 1 being rolled, 2 being rolled, 3 being rolled. Sometimes there's not a gap. So and that's called a continuous function. So the best simple demonstration of that is discrete could be just these dots. Nowhere else, just these dots. Whereas continuous would be a line. So there's no gaps. You can't see that there's an individual point. Like as soon as you get to a particularly small point, you can go even smaller. And since we can't use the summation on continuous events because it goes infinitely small, the summation sign, the equivalent in continuous functions, ends up being the integral. So summation, integral, and that's just, I didn't really write it very well, but that's an integration sign. You have your lower limit at the bottom, your upper limit at the top. So the equivalent of your summation, you do it over all of the possible values multiplied by the probability or the function. So in this particular case, you'd have your expected value of the random variable x equals the integral from negative infinity, we'll say, to positive infinity of x, which is a continuous value or continuous set of values, multiplied by the function at x with respect to x. So that is how to find the mean of a function, and that may mean that if it's a simple function, you may find that the mean might be 0 if it goes positive and negative. It's like a zero mean sinusoid. Some other things that might be of importance is that if we were to write something like this, we have the expected value of x squared, this will give us a different perspective on being able to look at the signal or the function. So it's the same thing as the expected value of x, except we swap out x for x squared. So this is, you can go to higher ones, so the expected value of x cubed, expected value of x to the fourth. It starts to get a bit trickier, a bit more involved. But for the time being, if you can remember that the expected value, the mean value, is the integral in a continuous domain, the integral over all possible values of x multiplied by the function at those values of x with respect to x, and e to the x squared is the same